The quality of a fuel car depends on its three major parts, just as new energy, pure electric cars also rely on three key components: the motor, battery, and electronic control. Mastering these three parts is essential to making an excellent pure electric car, which is why even internet companies now dare to venture into car manufacturing. A pure electric car cannot function without its motor, which generates a rotating magnetic field once powered on, causing the motor to rotate and convert electrical energy into mechanical energy. There are two common types of motors. Foreign manufacturers generally use AC motors like Tesla, while domestic car companies often use permanent magnet synchronous motors. The second major component is the battery. The power of the car comes from the battery pack, which is divided into 16 smaller modules. Each module contains hundreds of small batteries, amounting to thousands of small lithium batteries in the entire electric car's battery pack. These lithium batteries are not much different from the batteries we use in our daily lives. They are combined in series and parallel configurations. Inside the battery pack is also a cooling system. Coolant flows around the batteries to dissipate heat. The use of small batteries aims to achieve a uniform temperature distribution and better heat dissipation, ensuring each battery is cooled and extending the life of the battery pack. However, since the battery pack provides direct current and both synchronous and asynchronous motors use three-phase alternating current, an inverter is required to convert DC into AC. In this energy conversion process, an electronic control system is also necessary, equivalent to the ECU of a traditional fuel vehicle, allowing the vehicle's hardware and software to work together seamlessly. For example, the battery needs a battery management system to monitor voltage and current, while the motor requires a motor control system to manage DC to AC conversion. Electric vehicles do not need to switch gears like traditional fuel vehicles. Their acceleration and deceleration are controlled simply by changing the current's magnitude and frequency. Therefore, their transmission system is very straightforward, directly connected to the differential, and boasts a high response speed. Electric vehicles typically feature energy recovery systems. When going downhill or braking, the battery stops supplying power, and the motor acts as a generator using wheel inertia to generate electricity. This electricity is then stored back in the battery pack, achieving energy recovery. Because electric vehicles lack complex engines and transmission systems, their body costs are lower than those of traditional fuel vehicles. However, due to the high cost of battery packs, which account for about half of an electric vehicle's total cost, the overall price can be significant. If you had to choose again, would you opt for a traditional fuel vehicle or a new energy electric vehicle?